So in 8.1 we talked about the idea that when you are solving for a quadratic function, when you have y equals ax squared plus bx plus c, and you set it equal to 0, and you're solving for x, whether it's by factoring, whether it's by square roots, or whether it is by quadratic formula, what you really are trying to find is the 0 of the function. The 0 of a function is the value of x when y is 0. In other words, this is synonymous with the x-intercepts. It's also synonymous with the word the roots of the equation. When you're asked for the roots of an equation, or when you're asked for the roots of a quadratic, you're literally trying to find where it crosses the x-axis, which means you're substituting 0 for y and solving for x. You guys have already solved for x by by quadratic formula, by factoring, and by square roots. When you found what x was equal to, you were finding the roots. You were finding the zeros of the function. You were finding the x-intercepts. They all mean the same thing. Now, when we're talking, and we kind of mentioned a little bit about this yesterday, when you're talking about a quadratic function, we know that it graphs into a parabola. We talked about the fact that a parabola, which makes the U shape, is really symmetrical. And the vertical line that cuts it in half is called the axis of symmetry. The axis of symmetry is an x equal to equation. So x equals 3 is this axis of symmetry. The minimum is 3 because that is the lowest point that it goes through. 3, 0. That is the minimum. The axis of symmetry always goes through the vertex. The x equals value will always be the x value of the x with that vertex. Sometimes, however, you are given a quadratic parabola and you're not told exactly what the x equals axis of symmetry is. And so what you do is, if you are given the roots, if you are given the zeros, if you are given the x-intercepts, remember these are all the same words, roots, x-intercept, the solution, all of these mean the same thing. And if you can see that the x-intercept is, for example, in this case, -4, 0 and 0, 0, you know that the axis of symmetry has to be the vertical line that is halfway between these 2 points. And how do we find the middle between 2 points or between 2 values? We take the average. If you want to know where exactly the axis of symmetry is, if you are given 2 points, you find the average of the x's. So -4 plus 0 is -4, divided by 2 is -2. That means that you're going to go through -2 on the x-axis because that is the middle. So when you are given 2 zeros in a quadratic, the 2 zeros are also the x-intercepts, that's the word. If they ask you for the axis of symmetry, you are going to average the 2. Sometimes you will not be given the vertex where you can just get the axis of symmetry by this way, and you will not be given the 2 points that cross the x-axis so that you could just average the x values and get the middle. Sometimes you're going to be given an equation in quadratic function form, y equals ax squared plus bx plus c, and in order to get the axis of symmetry, you have to use a formula. Kind of like the quadratic formula solved for x equals opposite b plus or minus the square root of b squared minus 4ac divided by 2a. This part of the quadratic formula is the part that finds the axis of symmetry. the part that finds the axis of symmetry is the negative b over 2a part. So if you use x equals negative b over 2a with a quadratic function, you will find the axis of symmetry. And that is simply just substituting a and b into the x equals negative b over 2a. So there are three ways of finding the axis of symmetry. Way number one is if the vertex is given to you, you know the axis of symmetry is x equals wherever the 3, in this case, wherever the vertex crosses the x-axis. Way number two to get the axis of symmetry is if you are given two roots. If you're given the two roots, if you go through 2 points on the x-axis, the average or the middle is the axis of symmetry. And the third way is using the formula for the axis of symmetry, which is x equals negative b over 2a. So if I'm given an equation or a quadratic function such as y equals 2x squared plus 4x plus 5, if they ask me what is the axis of symmetry, you say x equals negative b over 2a, plug it in, and you get the fact that the quadratic that makes this graph is going to go through -1 on the x-axis. So if I was to quickly draw it, I could go to -1. I could make a vertical line through -1 because that's my axis of symmetry. And I know that that's where I'm going to go through. The other thing that you could see is, remember that C is the y-intercept. So that means that you're going to go through 1, 2, 3, 4, 5 on the y-axis. That's all that I could tell right now from this information. I am going to teach you how to find the vertex and how to be able to graph the rest of the parabola. But as of right now, the only things that you can tell are, based on the equation, you can now get the axis of symmetry by using x equals negative b over 2a, and you can identify the y-intercept, which is the C. That's all you could tell. You don't know where I cross the x-axis unless you factored this. If you factored this or used the quadratic formula, x equals negative b opposite b plus or minus the square root of b squared minus 4ac all over 2a, what you get for x equals, that would be the x-intercepts. So let's talk a little bit more about that stuff. So let's practice finding the zeros and the axis of symmetry. If I asked you what are the zeros of this, what does the word zeros in this case represent? What's the synonym? When they ask you to find the zeros of a function, what they are asking you to find is the x-intercepts, or the roots, or the values of x when y is 0. So the zeros are this and this. This is really -1, and this one is 3. So the zeros are -1, comma 0. That's my point. And 3, comma 0. But the x value is -1 and 3. If you remember how you solved these before, you guys were supposed to solve this. You set it equal to 0. You use the quadratic formula or you factor, and these are the two solutions. So when you are given a graph, you can tell what the solutions are just by looking at where they cross the x-axis. What is the axis of symmetry for this quadratic?
1.
Well, the axis of symmetry is the vertical line that goes through the vertex. Here's the vertex, right down here. So the vertical line that goes through it is this here. Remember, axis of symmetry is an equation. What is the axis of symmetry? An equation. The axis of symmetry is an x equal to equation. Why is it x equal to? Because it's a vertical line, remember? The axis of symmetry in this case is, notice how I go through 1 on the x-axis The axis of symmetry is x equals 1. Do you see that? What is the vertex? What is the vertex?
1 and negative 4.
1 comma negative 4. So the vertex is this point right here, 1 comma negative 4. The axis of symmetry is the x equal to equation that goes through the vertex. So now you guys try. I want you to tell me what is the axis of symmetry. Remember, axis of symmetry is always an equation, so it's always going to be x equals something. So find the axis of symmetry. I want you to find the roots, and I want you to find the vertex and tell me whether it's a maximum or a minimum. Good, yes. Awesome. So, axis of symmetry is the vertical line that goes through the vertex. It's the one that's right smack in the middle of everything. So if I was to create an axis of symmetry, I would make a dotted line like this. The axis of symmetry is the equation x equals, and if you think about it, if this is negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, I am going through negative 4 on the x-axis, so my axis of symmetry is x equals negative 4. The roots are where I cross the x-axis. What are the roots? Or roots, plural? What is it? Where do I cross the x-axis? At negative 4. So the root says that x is equal to negative 4. It's coincidental that the vertex, which is located at negative 4 comma 0, is also the root. That means there's only one solution. Remember, there's 3 possibilities with quadratics. You could have 1 solution, 2 solutions, or 0 solutions. Is this a maximum or a minimum?
A minimum.
It is a minimum. Okay, let's try this one. So, let's see. Axis of symmetry. Well, if I was to draw a vertical line through the center, that's it. It's this one right here. It is the y-axis. So x equals, remember, axis of symmetry is always an x equal to because it's vertical, vux. X equals, what is x equal to? 0. You went over 0, correct? The y-axis, the equation of the y-axis is x equals 0. Are there roots to this quadratic? Do I cross the x-axis at all?
No.
So this would be a no solution.
So don't you cross at 0?
Where do I cross the x-axis?
Oh, you don't.
You don't cross the x-axis, correct? Remember, roots are the zeros, which are where I cross the x-axis. It's, if you were asked to graph this, if you were asked to solve this using factoring or the quadratic form, you would get no solution. What is the vertex? Right here. What is that point right there called? No? 0, comma, negative 2.
It looks like the 0.
Is this a maximum or a minimum? It's a max. Okay, I want to show you how if I solved this equation the way that we did it with the last unit, where you set it equal to 0 and you solve, I want you to see how it's going to be no solution. When I add 2x squared to both sides, I get 2x squared is equal to negative 2. I then divide by 2, and I get x squared is equal to negative 1. I go to take the square root, and oh no, no solution.
Could I just do that?
So last unit, we learned how to solve by doing this, and you got no solution. What this meant graphically is that when you graph this equation on the coordinate system, you are not going to cross the x-axis. That's why you got no solution. So when you're given a graph, if you do not cross the x-axis, it means there's no solution. And mathematically, that's what it's telling you right there. So even though this is a section 3, I want you guys to see something. It's all related. That's why we're going through all this at the same time. When you're graphing a quadratic function, remember I told you that the c of the y equals ax squared plus bx plus c, the c is the y-intercept. And if you remember what it means to be a y-intercept, the y-intercept is the value of y when what? Exactly, the value of y when x is equal to 0. So if I knew that from my early Algebra 1 days, then what you could do is you can look at this and you can actually solve for your y-intercept if you plug in 0 for x. So if I had this guy without my graph, and I know that my y-intercept is the value of y when x is 0, and I plug in 0 for x, I'm going to get y equals 0 squared minus 2, which tells me that when x is 0, y is negative 2. And the mathematicians did this over and over and over again with every kind of quadratic. If I was to plug in 0 for this equation, for x, to get the value of y, my y would equal 0 squared minus 4 times 0 plus 4. When x is 0, y is 4. So without even having to do the math, it's really convenient to understand that when you have a quadratic function, the c, the constant, is the y-intercept. Okay? So that you can then graph the rest. Notice that here, y equals x squared minus 4x plus 4, I cross the y-axis at 4. And this one here, y equals negative 2x squared minus 6x minus 3, that minus 3 is where I cross the y-axis. So that's just an additional way of finding the y-intercept of a quadratic function. Now, we talked just a little bit about the axis of symmetry. And the axis of symmetry is a formula that is used to find the x value of the vertex. Because if I go through the vertex, what I'm really finding is the x value of the vertex. X equals negative b over 2a is the formula to find the axis of symmetry. The vertex is either the maximum or the minimum of the parabola. All words that we've learned. If I was to draw different parabolas, I could say, here we go. Draw an axis of symmetry. Well, I'm making one up. 1, 2, 3. Let's say that this is negative 4. And the vertex may be negative 4, comma, negative 5, let's say. Where x equals negative 4 is the axis of symmetry. The x of negative 4 represents the x value of the vertex. Always. The x equals the number that you get for the axis of symmetry is the x value of the vertex. Always. So let me ask you a question. let's say that I give you an equation that looks like this. If I gave you this equation and I said to you, hey, graph this, as of right now, what you could do is make a table of values, pick some x values here, plug them in, get the y's, and then you get your points. But there are a couple of things that you should be able to immediately get right now. First of all, you should be able to find the zeros, which are also the x equals amount, the x-intercepts, by factoring, using the quadratic formula, or using a square root. The second thing that you can do is you can find the axis of symmetry. Because the axis of symmetry is x equals negative b, negative of negative 3, over 2 times a. Now, unfortunately, I picked fractions. This gives you 3/4. X equals 3/4 is the axis of symmetry. Let's look at this equation here. If I asked you to find the axis of symmetry, you know you would use what equation? So the axis of symmetry is a vertical line, So that means your answer is going to be x equals, not just a number. You're going to write x equals, and the axis of symmetry is x is equal to the opposite of b, so opposite of negative 8, over 2 times a. That gives you 8 over 4, which is 2. The axis of symmetry is x equals 2. If I asked you for the vertex, remember that the axis of symmetry goes through the vertex, right? If the axis of symmetry is going to go through the vertex, that means that the vertex is going to be whatever that x value is, 2 comma something. How do I get the value of y if I know what x is equal to? Very good. You have the equation. Y is equal to this. So if you're trying to find out what is y equal to when x is 2, then what you're literally going to do is just plug that in. You want to know what is y equal to if in my equation all of the x values in this case are actually 2. Because if the vertical line that goes through the center, okay, if the vertical line, now I'm going to draw a little picture on the side. If I have a parabola and the vertical line that goes through the center is going through the number 2 on the x-axis, that means that this point has to be 2 comma something. And in order to get the something, you plug in the 2 for the x value. Now, if I do the math in order of operations, 2 squared is 4. 4 times 2 is 8. 8 minus 16 plus 5. 8 minus 16 is negative 8. Negative 8 plus 5 is negative 3. That means that when x is 2, y is negative 3. I have now discovered the axis of symmetry, which is the vertical line that goes through my parabola. I have now discovered the vertex, which is in this case the minimum, 2 comma negative 3. And if I wanted to know where I cross the x-axis, my roots, I would either use the quadratic formula or I would factor. So here I am given the equation y equals 3x squared minus 6x plus 1. I know that this is the graph of a parabola because power of 2 makes a u. So if I'm asked to graph it, these are the steps that you follow in order to graph. Sort of like we talked about on the side of the whiteboard where we wrote down, what do I need to know in order to be able to graph a parabola? These are the steps to graphing a quadratic. Step 1 is to find the axis of symmetry. So in order for me to graph that function on this chart here, this coordinate plane, before I do that, I'm going to put him out of the way, we need to find the axis of symmetry. And hopefully you remember already, axis of symmetry is x equals negative b over 2a. Guys, I can't say this enough. When you find the axis of symmetry, please do not just say negative 1. It's x equals, because it's an equation. It may look like it's telling you what the variable of x is equal to, but it's an equation. And if you remember linear functions, Vux, Hoy, vertical lines, undefined slope, are x equal to equations, you have to write x equals or you're not answering the question.
Wait, isn't it 1?
So in this case, x is equal to, if this is a, this is b, and this is c,
6 divided by 6.
x is equal to the opposite of negative 6 over 2 times 3, which, yes, correctly, is 6 over 6, x equals 1. X equals 1. You cannot just write 1. It's x equals 1. What this is telling you is that on my chart, on my coordinate plane, right here, the coordinate plane is x equals 1 is my axis of symmetry. So if I wanted to start my graph, I would go to 1 on the x-axis, and I would make a vertical imaginary line. This is the x equals 1 part. I have discovered the axis of symmetry. Now, let's go on to the next part. To find the vertex, well, remember that if you are a vertex in a parabola, you're going to be on this x-axis here. I'm sorry, on this axis of symmetry. You're on this axis of symmetry. That means that you are going to be, in this case, 1 comma something. Your job is to find that something. And then you go back to the whole algebraic thinking. That if you found that x is equal to 1, and you're trying to find what y is equal to, you are going to plug in 1 for x to solve for y. Your equation is that y is equal to 3 times x squared minus 6 times x plus 1. And you know x is 1 in this case. You do your order of operations. 1 times 3 is 3 minus 6 plus 1. And you get 3 minus 6 is negative 3. And negative 3 plus 1 is negative 2. That means that your value of y is negative 2 when x is 1. 1 comma negative 2 is your vertex. That is where you cross at your maximum or your minimum. So I go to my graph again, and I'm going to plot 1 comma negative 2 right here. 1 comma negative 2 is my vertex. And again, how did I find that? Because I found the axis of symmetry. And the axis of symmetry is an x equal to equation. And if you're trying to find the point that you are with x equal to 1, you plug 1 into x to get y. Cool. Now we need to find the y-intercept. Well, y-intercept is C. If you are the y-intercept at 1, that means that your y-intercept, and again, remember that C is the y-intercept, so in this case, C is equal to 1. So that means I'm going to go and cross at 1 on the y-axis. And when I go to the y-axis and I'm crossing at 1, I am right here. That's my y-intercept. Now the y-intercept is located at 0, 1. That's my coordinate. That means that the y-intercept location 0, 1. Now I look at my graph and I go, wow, I'm almost there. I can look at my parabola function, and I know that because a is positive, it's opening upwards, right? I only need 2 more points. So remember that when you're finding x's and y's, it's easy to find out what y is equal to if you know what x is equal to. In order to find 2 more points, in order to make a really nice graph, I am going to choose some x values that are going to be then plugged in to find out the corresponding y values. So you choose 2 x values. That looks like the word valve, so I apologize. My V is not as values. To find corresponding y values. Because then you have xy and xy. That's basically what you're doing. So let's look at our graph again. Let's see. If this is my vertex, and I know I'm opening up, I probably want to know what happens at, I don't know, 4. Where am I on the 4? That's basically what I'm trying to find. So let's find out what y is equal to when x is 4. And because 4 is 1, 2, 3 units to the right, I know that of the axis of symmetry, I know that 1, 2, 3 units to the left, I'm going to reflect in that same location. Does that make sense?
Wait, but
Because the axis of symmetry is symmetrical. So, if I want to know what x is equal to, what y is equal to when x is 4, I'm going to get some value. I'll be able to reflect it over the axis of symmetry. Can you recognize a point that I can reflect right away? What about this one?
0 and 1.
If you're looking at your
0 negative.
graph here, do you see how I know this is my minimum right there? Do you see how this point here is literally 1 to the left of the axis of symmetry? If you want to reflect that one, you can immediately say to yourself, oh, well, if this guy here is just 1 unit to the left, I can reflect a point right here because it's symmetrical. Now I have 2 points. I have the x-intercept and this point. To get more specific, I am going to calculate that value when x is 4. So I'm going to choose another value besides the point that I just reflected. I am going to say, well, I want to know what happens when x is equal to 4. Here's my equation again. Y equals 3x squared minus 6 times x plus 1. I'm going to plug in 4 because I want to know when x is 4, what is y? 16 times 3 is 48. 48 minus 24 is 24. Plus 1 is 25. So when x is 4, y is 25. This means that if I wanted to make a point, now here, 4, 25 would go all the way up there. I'd be off the graph on that case. Do I have enough information to connect my dots and make my pretty little chart?
Yeah.
Yeah, you do. You've got your vertex, you've got a point, you got another point. So if I wanted to connect those dots and make a parabola, I would smooth it out, and I have my parabola. Notice that I go through those 2 points, and now I have my parabola. That is how you graph given only an equation. So given an equation, you find the axis of symmetry. You plug that x value that you find from your axis of symmetry into your function to get what y is equal to when x is that one value. That is your newfound vertex. You plot the point. You make that vertical line for your axis. You can identify the y-intercept right away by just looking at the C. And then you can choose some point, some value of x to plug in to get the corresponding y, but you could also reflect across the axis of symmetry. So when you have, here we have a graph. They're asking me to graph y equals 2x squared minus 2, right? So 2x squared minus 2 equals 0 is an equation. The related function is y equals 2x squared minus 2. The word related function is just how you would write it if it was a y equal to equation, okay? I would like for you to, on your own, find the axis of symmetry, find the vertex, the y-intercept, 2 separate points, and then graph the entire function.